Okay, so as we remember, our pump has a certain requirements. That means it is 715 watts and the operational voltage is between 48 72 volts, which means that if the solar panels are not able to deliver that power at this voltage, the pump should basically cut off. Or basically not be able to work, because that would be very heavy on the switching transistor to work on under voltage. Uh, okay, so I have brought 4 panels here. They are roughly installed using wire, and they will definitely not stay this way if they will stay here, because maybe we will move it somewhere else and we will bring some other panels. These are quite good quality panels. 600 volt system DC. It is in series. Where do we have the voltage output and so on? Volt 37 volt DC. So we need 2 of them in series. This is exactly what I'm going to do, and they are 250 watts. So they will definitely not deliver 250 watts at this voltage if the load is bigger. So let's try, just for the kicks, we will connect 2 of them in series, and then we will connect them to the driver. I didn't do that yet. So I have black one connected on the red, and this one, so we should have minus 70 volts about. And this is exactly what we get. This is Cyprus, but it's winter, so the sun is definitely not at its peak. We will get much more power. I mean, the sun can deliver here megawatts on that area of this plot if we cover it completely with the solar panels, but we are not going to do that, of course. Nobody does it. Well, some people try, but not really entire area. Okay, so let's connect it and see what we will get out of this pipe over there. Okay, so the wires are on, and is there anything on the display? Nothing. And if we get anything on the panel here, it's still the same voltage, 69 volts. I wonder, maybe we need to turn it on? Doesn't show anything. Again, voltage. There. $69. No, it doesn't do anything. I think we need to test if the voltage is maintained when we are pressing the button, but for that I need both hands. No, it doesn't do absolutely nothing. It doesn't affect completely the output of the whatever the this display is showing in my multimeter. So there is something else that isn't right here. Murphy always gets you. Always. In such sophisticated ways you cannot even imagine. So yeah, it works. Reason? Reverse polarity. Good heavens, thank you those who designed this circuit board that they prevented me from doing that stupid mistake. I did it multiple times. It always gets me. And moreover, I use my meter, but of course I reverse also polarity on my meter at the same time. So you know, these wires I just prepared, like, you know, I'm not doing that every day, so this is where the mistake came from. So let's try to switch it on right now. So it measures the voltage. Are we going to get anything? Or do I need to do anything more? Volt, RPM, tank, well, and PPT. Voltage gets down. So it draws something, or we get some clouds. It rather seems to me that it's taking the current. Yeah, we got water. Okay, so this is running on 2 panels only, so it's underpowered. But of course, let's not forget that the pump is also working on half depth. Although I don't believe it would have a huge influence on the efficiency of that. Okay, excuse this dust, but I was doing some sunlight polishing of the stone. Now it's connected with 2 panels, and it started to pump, and the voltage went down to 61 volts. This time the pipe is disconnected. I don't know yet where it ends, to be honest, so we need to go for a hunting. There must be somewhere a pipe with running water. I think it will come from here. Yep. So we have one tap. Okay, and it continues on, I think, around here somewhere. We have a water coming all the way to the roof. And it's a nice pressure. Okay, so I need to connect some tanks to this. Okay, so capacity of this tank is I don't know, it's like 3 meters 20, about 3 meters 20 I remember, and the depth is let's say about 50 centimeters, and as you can see, the light on the other end of the wall, yeah, is shining right just under these square patches. So it's from here. When we'll get to here, we will calculate more or less how many liters it went, and I'm gonna run the timer just roughly to know. Okay, unfortunately my lawnmower died. It gave a sound that I never heard before, and it was nasty, so I assumed the engine is dead. Unfortunately, I have another one that I didn't need for anything, but I fixed it anyway, and now I will probably make a swap of the engine, because this one is with the power drive, this one hasn't. It's a weaker engine, but you know, this stuff is growing right now. I have no time to fix the other one. And it's evening, and this angle of the sun is quite steep right now. The voltage is dropped insignificantly, I need to say. It's 51 volts at this point, and it's still running. So we will go upstairs and we will check how much, measure how much we can, and then we will know. So it's not entirely to the place where I wanted to have, but we know it was more or less about centimeter under the level of this patch, and now it's, let's take a look again. Now it's about 2 centimeters, maybe 2.5 centimeters under the top of the patch. So with the tape measure, it's about 12 centimeters, about 12 centimeters easily. Or no, wait a minute, it was the other one. But it will be the same because the length of the patch is about the same. Yeah, exactly, about 12 centimeters. Couldn't be different. I take a look again on the previous video, maybe it was a little bit lower, but I think it's about 12. Although I would say more about 13. Okay, so yeah, you will see the calculations over here. I'm not gonna continue this video because the battery is dying. More videos